So we've moved on to part C of our bonds and chains problem. And part C says for us to calculate the macroscopic spring stiffness constant of the wire if the interatomic spring stiffness is 28 newtons per meter. And wow, is that a mouthful. So basically what we're being asked for is a variable that is denoted by the letter K, which is more commonly applied when we talk about springs. So if we look at the force of a spring equation, this is going to equal the stiffness constant of the spring that we have times the length that this spring has stretched or compressed from rest. So what we want to look at is the stiffness constant of the wire. What we have is an interatomic stiffness. So if we look at the K constant of the wire, it's basically talking about how much give these atoms are going to have when their bond length is starting to stretch or compress, how close together or how far apart these atoms can be from each other, talking about the stiffness. So what we want, given these three values, two of which we calculated, we want the macroscopic spring stiffness. So we're not talking about finding the microscopic, which is the interatomic spring stiffness. We're not talking about finding the value that we already have. We're talking about macroscopic, the entire wire, when the entire wire as a whole stretches or compresses, how much stiffness it's going to have. So we want the stiffness constant of the wire macroscopically, macro. And just like parts A and B, we do have an equation which we are going to use to calculate this macroscopic stiffness. And this equation is, it's a bit long, the macroscopic stiffness of the wire is equal to the number of chains, n chains, divided by the number of bonds times the interatomic spring stiffness. And of course, just like parts A and B, all we have to do is plug in these numbers that we already know to solve for the value that we're looking for. But of course, we couldn't have used this equation without knowing the number of chains and the number of bonds from parts A and B. So that's why we had to do that first. But of course, now we are just going to plug in all these values. So the number of chains is 6.06 times 10 to the 13th. And the number of bonds is 1.17 times 10 to the 10th bonds. And this value in parentheses is going to be multiplied by 28 newtons per meter. And of course, all we have to do is plug this into our calculator. And once we calculate all this out, we get that the macroscopic stiffness constant is equal to 1.45 times 10 to the 5th newtons per meter. And that tells us that this is a fairly strong wire, but regardless, we have finished part C of our problem, having solved the macroscopic spring stiffness of the wire, and with that our problem is finished.